All right, continuing with our discussion about some legal issues that relate to human genetics. I thought I'd go through one specific area. Again, we'll talk a lot more about this as we go through other parts of the semester, talk about testing, talk about some of the other things involved. But here I thought I'd share some sort of interesting things that occur that relate to this idea of testing and other things. So one of the areas that we have under legal issues is this idea of sex verification. And that's an important legal distinction. I mean, of course, now people can define their genders and how they want to be called and things based on work. But in certain areas, we need the verification for these things. And one of those areas it tends to be in athletics. And I think it's a good one to point out some of the legal issues that have occurred. So if we look at this, I want to look at two examples, Mary Louise Weston, and Maria Patino, and look at some of what how these arose and what they relate to. Again, this is in particular related to athletics. All right. So Mary Louise Weston was born in 1905 in the UK. She was known as the Devonshire Wonder, and for that reason, because she had great athletic prowess. She was, brought up, and she did a number of things early on as champion. She was UK national champion in the javelin throw, as well as the discus throw. That was in 1929. She had already been a women's champion in shot put in 25, 28, and 29. And in 26, she went to the Women's World Games, which were sort of a version of the Olympics. And she placed sixth in the two-handed shot put. Two-handed shot put is where you throw with your right hand a shot, and then you turn around, take the same weight, and throw it with your left hand, and you get the average of those. A very difficult thing to do for most of us to throw with both hands. But she had great prowess in this. That's why her name came about. Okay. Well, after the 1936 Olympics, which she was involved in, as well as some Russian individuals that came in, there was some questioning about sex verification of these individuals. There was some challenges about how they could do so well, their physiques and other things. And so after the 36 Olympics, there came a very strong request from the groups nations to try to start sex verification. This was spurred on by the fact that both of the athletes that were part of the Olympics that brought this to people's attention, but particularly Mary Louise, shortly after those Olympics, she went through a gender change. So she was brought and now took on the name Mark Weston, later married, had some children, etc. She was basically an intersex individual. And so the gender correction that she went through brought her to, male component. So she was most likely, I don't know the genetics was actually done, but she was probably an XY individual, well, obviously in some form, so she could have reproductive components. Now, this verification of this, and she lived the rest of her life as Mark Weston in a relationship. It went on for quite a bit of time, but this request for verification, how do you do it, and things. By 1950, the IAAF, which is the International Association of Athletic Federations, which governed much of the athletic activities of the world competitions, decided to start having sex verifications. And it was a fairly, humiliating sort of thing. You basically, it was only for females, you had to strip down, okay, become, and literally parade yourself in front of a line of physicians to verify that you had components, that secondary sex components at least, that would distinguish you primarily, as a female. And this went on for a large period of time, and still, in some ways around. And then in 1968, because you may remember from the history lecture that we did, but way back sometime, we talked about the fact that one of the techniques that came along was chromosomes, functioning chromosome banding. Well, by the 68, it had become a lot simpler. You didn't have to take whole tissue samples. You could take saliva and other things. swabs, and you could do chromosome testing. Now, it took a long time to do it, but you could do it. And so between 68 and about 1999, there was a mandatory chromosome testing for all women who were participating in Olympic games. And there was also this other, visual vision and several other things. Okay. So those were, and we were obviously picking out one sex, not the other, and testing them. So there was this, whole discrimination against female type things, and brought on by, this, okay, if you're going to be a male, if you're going to be a female, you need to compete as a female, but you have to prove that you are one. Okay. And a lot of it had decent intentions. There were national programs out there which they were providing testosterone and steroids and things to females to make them more masculine, have more strength and things. So there was a lot of different ways of cheating and doing things that to individuals. So it had some real merit to it, but it was still very discriminatory. Now, one of the big cases that sort of brought this finally kind of to great attention and led the way to do away with this chromosomal testing. Now, that's not saying that gender testing is not still done. Sex testing is still done, but only in special cases, only when there's great need, and it's this antigen test and things. It's not done unique, worldly. You don't have to go in and prove. But you did at one point, okay? This is Maria Martinez Patino, and she was from southern Spain. She was brought up as female. She was female. There was no question about it. That was her gender. That was the way she was raised. And she was a very gifted athlete. She was particularly gifted in the hurdles, and so she was able to jump and run. In 1983, she was given a certificate of femininity, which involved her, again, disrobing and parading in front of physicians, and she was given this form. She went to the World Universal Games in Japan in 1985, and as it says, she forgot to bring her certificate. Okay, so because she didn't have her certificate, which is shown, here, right? She had to go and be tested again. Okay. And so when they did the test this time, they had introduced this idea of chromosome testing. Okay, now she tested and was retested, and they failed her. Okay, unfortunately, it was going to take months at that time to still then to get a good test back. But the problem was, they said, well, you failed the test. And we need, proof. It's going to take a while to do that, to get the test actually confirmed. So, and just of course, as you would imagine, here's an elite athlete who's trained, goes to things and told you can't compete. In fact, she didn't compete. She was suggested that she withdraw based on claiming that she had an injury, and reluctantly she did this because she didn't know what was wrong. Her brother had passed away from leukemia. They hadn't really told her what was wrong. They just said, you can't compete, and there's other things we've got to test before you can compete. They didn't say, oh, by the way, we apparently are a male or something. Okay? Well, she went ahead and went to the 1986 Spanish National Championships. She won, but she was disqualified. And what's going on here is that by this point with this karyotyping, they had realized that she was a normal 46 chromosomes, normal autosomes, but that she was an XY individual. So genetically, she was male from a standpoint of her chromosome count. Okay, and so this was the classic problem, and they said, well, you're going to be disqualified, right? They actually did. She fought this in 1988, and her license was reinstated as a female, and she was defended by geneticists as who served as an expert witness, and we'll talk about what it takes to be an expert witness at some point. And eventually, she described her experience in a Lancet article, a scientific journal, The Lancet. And it's actually really good. You should probably read it if you have a chance, about her experiences and what happened. But basically, she was reinstated, and but she had been, the next games that she really could be in was 1992. She had, by 1990, 89, she had been out. She tried to get back in, but she missed it by a few hundredths of a second to actually make it, and that was the end of her career as a top level athlete. So what's going on here? Well, we have this test, right? We have this karyotyping test. This is an individual who had passed test as a female. The visual test was raised as a female. That was her voice. There was never any question. In fact, it was she was embarrassed to go tell her parents that she wasn't a female genetically, and it was a big issue for her. So what was going on? Well, this individual had a classic case of what's known as antigen insensitivity syndrome, AIS. Now, there are two forms of this. There is complete CAIS and PAIS, which is partial. And they come about from different mutations and different outcomes. Complete, which is what Maria had, you don't have, you have XY, but you're unable to receive the testosterone, the antigen, the receptors are not there, okay? And so you don't express pretty much any of the male characteristics. You don't have, the pubic hair system is different, and the secondary sex characteristics patterning. They don't descend, even though they may have testes, they never descend. In fact, people that have complete, that are, and it's obviously primary males because it's carried on the X chromosome, right? So most of the time it's male. Well, it is male. When it's carried on the X, it is carried as a sex-linked or X-linked recessive. And so much like color blindness or something. So obviously most delete are going to be males. In order to have a female and to have it, to have the antigen, you'd actually have to have it coming from dad and from mom. You have to be a homozygote. So we see males or individuals that are XY who primarily show this antigen insensitivity because they don't produce, they can't perceive the right antigens. And obviously it's targeting testosterone anyway, so it's really looking male. So these are individuals that come up as females. The scientist that was the expert witness was Albert Chappell, and he had been fighting for a long time against this chromosome test. Anyway, the sex determination by chromosome testing, because of examples like this form. Now, genetically then, what are we talking about here? Well, as I said, we're talking about a gene, an gene that's found on the X chromosome. It's around Q11, Q12, so it's up close to the centromere. Remember, the X chromosome is very large, okay? The gene itself has about 8 exons, number quite a stretches of introns. These 1, 2, and 3 are introns, and then this 1, 2, 3, 4, 5 are exons. The DNA that is from transcription, once you get all that matured and out, it looks something like this, okay? And we end up with a corresponding form. There's transcriptional regulation, it's a receptor protein, there's DNA binding, because what it does is, and then steroid binding, okay? So what it does is it sits out in the cytoplasm. When testosterone comes in and is moved into the cell, it connects with this AIS, which is the AR gene, or protein as it's called, and couples. That causes a release that then causes that AR protein to move into the nucleus. It comes transmembrane into the nucleus, and it then regulates, right? It's a classic regulatory, it's a transcriptional regulator. So by having this form, in that transcriptional regulation, it goes through a number of enhancers, and you end up with quite a bit of expression of things we would think of as maleness, okay? Zinc fingers, classic zinc fingers, those are, very common for in proteins for DNA binding, transcriptional regulation. There's a unit in here that allows it to move across the nuclear membrane, etc. Now, there are lots of variants of this. I've got written up here, there's at least 800 plus known mutations that occur in this gene. A lot of those are not, the mass majority don't cause AIS. They're simply mutations that are known. A big majority of those come because there's a big uh, trinucleotide repeat region, a CAG repeat region found in the gene, and a lot of the mutations have to do with different numbers of those repeats being found there. So they're calling those mutations, but they don't have a huge effect on the protein. But there are others that have a bit of an effect, and that's because we have all these different levels of mutation. You have a fully functional or partially functional or completely dysfunctional protein, as in the case of Maria. And so it just varies. Depends on that's how you get complete AI, AIS, or complete or incomplete AIS, is by which one of these mutations, where it occurs, and some are in the steroid binding region, so that even though you get the steroid and they could move in, they don't bind. Others are in the transcriptional region, etc. Okay? All right, so that's just an example of, here's a situation where it was codified, legalized in a sense, by these athletic governing bodies, that we needed to verify someone's sex. A series of mechanisms were put in place to do that. One of them was this chromosomal mechanism, and this person's life was affected, for her entire life was affected by the fact that even though morphologically she's female, right, as far as function, but her genotype is XY, and by the codified laws, by the rules in which she engaged in athletic sports, she was defined as a female, or excuse me, as a male, or they for a long period of time. And you see that this was 1980, 88, 92. It wasn't until 1999 that they actually quit doing this on a routine basis. But this was one of the classic stories, and her story that came out in Lancet in 2005 was really one of the things that, when they started talking about this in these organizations, that was always brought up. Here's an example of, here's something that's going on that's just wrong. All right, so that's about this. We'll talk about some of the other standards about legal systems and what's required, and we'll use examples. I think fingerprints will be a good example that we can use. So we'll talk about those in the next lectures.